Okay, this example is about solving the differential equation of this higher order DE. So this DE is in second order first degree. So to do this, we will replace every derivative to its equivalent m. So for this, second derivative, this is equivalent to m squared. Then for this, there is no derivative here in 4y, so this is simply 4m raised to 0, or simply 4 equals 0. Then after converting the derivative to m, we will solve for the roots. So for this, m squared minus 4, m is either positive or negative 2. So let's say m1 is positive 2, m2 is negative 2. Then after solving the roots of this equation, we will use this m in the general solution of the differential equation higher order. So y equals c1e m1x plus c2e m2x. So our m1 is positive 2, then c2e, our m2 is negative 2. Since we have a condition, so we need to solve for the values of c1 and c2. So this will be our first equation. So since we are solving two unknowns, we need two equations. So our second equation is the derivative of the first equation. So this is y prime. This is 2c1e 2x. This is negative 2c2e negative 2x. So using the conditions, our equation 1 is now, with this condition, y is 0. So this is 0 equals c1 e raised to 0 because x is 0. So this is simply c1. Plus, same thing with c2e negative 2, then replace x with 0. This is c2 only. So for the second equation, y prime is the first derivative, dy over dx. And with this condition, y prime is 3. And 2c1 e raised to 0 is 2c1. Then negative 2 c2. Then solving for c1 and c2, solving c1 and c2 using equations 1 and 2, c1 is 3 over 4, while c2 is negative 3 over 4. So using the first equation and using the values of c1 and c2, our final answer here is y equals 3/4 e raised to 2x plus, or this is now negative 3/4 e raised to negative 2x. So this is our final answer for this problem. Okay, consider the second example. This is in third order DE. So this is the given problem. Solve the DE of y triple prime minus 4y double prime plus y prime plus 6y equals 0. With these conditions, x equals 0, y equals 0, y prime equals 3, and y double prime equals 0. So we will replace y by m. So this equation will now be m cubed minus 4m squared plus m plus 6 equals 0. Solving for m, or the roots of this equation, we have negative 1, 3, and 2. So using these values of m, we have this first equation. We have this format or general form. Y equals c1e raised to this root, then with x, plus c2e, then raised to this root 3 with x, plus c3e raised to the third root 2 with x. So we need to find here the values of c1, c2, and c3. So we need 3 equations. This is our first equation. For the second equation, this is simply the derivative of the first. For the third equation, this is simply the second derivative. So this is our 3 equations. With the following conditions, let us substitute these conditions to these equations. So we have now equation 1, 0 equals c1 plus c2 plus c3. Equation 2, 3 equals negative c1 plus 3c2 plus 2c3. Equation 3 is now 0 equals c1 plus 9c2 plus 4c3. Then using your calculator, you can solve c1, c2, and c3, or solve this simultaneously. It will give c1 negative 5 over 4, c2 negative 3/4 or 3/4, c3 2. So using this c1, c2, and c3, substitute this to equation 1 here, then you have now your final answer as y equals negative 5 over 4 e raised to negative x minus 3 over 4 e raised to 3x plus 2 e raised to 2x. So this is our final answer for this problem. Thank you for listening. Please subscribe to this channel. Please like and share.